Welcome everybody. This is R4, section R4, polynomial long division. So we will be dividing polynomials today. So some information about dividing polynomials. When you divide two polynomials, first you must write the polynomials in standard form and fill in any missing powers of x. The final result of your long division should be the quotient plus the remainder over the divisor. And this goes for any long division, polynomial or not. Okay, so before we begin, let's list some important items. The first polynomial is called the dividend. This is the polynomial that is getting divided. This will go inside our division symbol. Excuse me. And then the second term is called the divisor. Okay, so like the instruction said above, it said make sure all powers are accounted for. Well, what we're talking about is make sure all the powers are accounted for in the dividend. So if we look at the dividend, we see that we have x cubed, x squared, and x. And then we end with the constant, as a polynomial should. So this looks like all the powers are accounted for. If we were missing a power, we would have to account for it. So maybe we'll run into those situations on the next one. Okay. Since all powers are accounted for, we can go ahead and set up for long division. So first thing we will write is the divisor. And we do not need to account for missing powers in the divisor unless you really want to, but there's no need to. Only the dividend. All right. And then we draw our division symbol, or you can even say division box, right? And inside we put the dividend. 3x cubed plus 4x squared plus x plus 7. And now we have to figure out what could we multiply the divisor by to help us get rid of the first term inside the division. So how do we get rid of the first term in the dividend? So there's a lovely little trick to that. And I'll do a little side work section over here. We'll call it side work. So if you do not know what to multiply by, well, the trick is take the leading term of the dividend and put it over the leading term of the divisor. So 3x cubed over x squared, and now reduce. 3x cubed over 3x squared gives me 3x. 3x is what we are going to multiply the divisor by to help us get rid of the leading term of the dividend. So what I'm going to do next is take this 3x and write it above the place of the dividend, the x place. So I'll put a 3x here. This tells us what we're going to multiply by. So now, still in the side work section, I take 3x and I multiply it by the divisor over there. X squared plus 1. Go ahead and distribute it, and you'll get 3x cubed plus 3x. Now what we're going to do is take this term and put it underneath the appropriate places in order inside the division symbol. So I'll have 3x cubed. We did not get an x squared out of it, so just go ahead and leave it blank. If you want, you can account for a missing x squared by putting 0x squared. There's no harm in that. And then we got a 3x, and we didn't get a constant. So I'll just put zeros to show you how we account for anything missing. Okay. And then I'll put our subtraction line there. So now remember that inside the division symbol, we have subtraction, which is how our terms will cancel. So 3x cubed minus 3x cubed, gone. 4x squared minus 0x squared is 4x squared. Now, here's where we have to be really careful with our signs. X minus 3x. X minus 3x. If you need to write it down, right? X minus 3x would give us negative 2x. So that's what it has to go right there. And then 7 minus 0 is, of course, still 7. Okay. There's the first breakdown. Now we want to know, can we go further? We ask ourselves, can x squared still go into x squared? And the answer is yes, x squared can go into x squared. So what do we multiply by again? Well, once again, you can use the side work trick. We take the leading term of the new dividend and put it over the leading term of the divisor. 4x squared over x squared means we will multiply by 4. And this number will go right there, right above the constant place. So, plus 4. Okay. And now take 4, multiply the x squared plus 1. So just do everything step by step for this one. And we'll get 4x squared plus 4, which is going to go underneath the new dividend. So 4x squared, we didn't get an x, so you can leave it blank. Or again, you can account for it, plus 0x plus 4. Operation is subtraction. So now 4x squared minus 4x squared, cancel. Negative 2 minus 0x, negative 2x. And 7 minus 4 gives us positive 3. And now we are finished because x squared cannot go into x. So this is it. So now how do we write our answer? Well, we have to know the pieces of our answer. Whatever we multiplied by, which is up here, this is called the quotient. And of course, you know, whatever is left over is called the remainder. And then you also know whatever you divided by is called the divisor. So the way we write our answer is we say the quotient, 3x plus 4, plus the remainder, negative 2x plus 3 over the divisor. And that's our answer. That's it. Quotient plus remainder over divisor. All right, not bad. So that's everything we do for long division. So watch, watch, watch your signs. Watch your signs. Okay, let's do it again. Okay, this time let's look at our dividend. And we have x to the fourth, x cubed, 2x, and negative 5. So we are missing a power. We are missing x squared. So this means we have to account for the missing power. So this means we will rewrite it as x to the fourth minus 3x cubed plus 0x squared plus 2x minus 5. So that's it. That's all the rewrite consists of. Putting a placeholder for that missing power. So 4, 3, 2, 1, 0. All powers are accounted for now. And then divide the same thing. Okay, we're ready to set up. Divisor, x squared minus x plus 1. Division symbol. And inside my dividend, x to the fourth all right, everything's set up. Divisor on the outside, dividend on the inside, all powers accounted for. Now what do we multiply by? And we can do the side work again. Take x to the fourth, put it over x squared, and that'll give me x squared. So that'll go right above the proper place, x squared. And now take this x squared and multiply the divisor by it. So I'll speed things up and just do it. So x squared times x squared gives me x to the fourth. X squared times negative x gives me negative x cubed. And x squared times 1 gives me x squared. Operation is subtraction. So your x to the fourths are gone. And now again, here's where you must be careful with your sign. Negative 3x cubed minus x cubed. Write it down if you need to. Negative 3x cubed minus x cubed. Plus negative 2x cubed. That goes right there. And then 0 minus 1x squared. That is just going to be negative x squared. And everything else comes down. And we do the trick again. X squared can definitely go to the x cubed. So we take those two and put them over each other. Negative 2x cubed over x squared gives me negative 2x. And I'll put that up there at the top, negative 2x. And take it and multiply the divisor by it. And I'll get negative 2x cubed plus 2x squared minus 2x. Operation is subtraction, meaning negative 2x cubed minus 2x cubed, gone. Negative x squared minus 2x squared. That should give me, I'll just do it in green, negative 3x squared. Negative 1 minus 2x squared is negative 3x squared. And then the next one, 2 minus negative 2 minus minus is going to make positive 4x, and that 5 comes down. Okay, we can keep going because x squared can go into x squared, and once again we can use the side work trick. Negative 3x squared over x squared will give me negative 3. And multiply, well, first, don't forget to put it at the top where your divisor is. Oops. There goes my minus 3. And now we're ready to multiply our negative 3 by the divisor. So we'll get negative 3x squared plus 3x minus 3. Very, very important to watch all your signs. Operation is subtraction, so negative 3x minus 3x squared, gone. 4x minus 3x gives me x. Negative 5 minus 3 makes that negative 5 plus 3. Negative 5 plus 3 gives me negative 2. Okay. There we go. Let's look at our answers. There's my quotient. There's my divisor. Not my divisor. My remainder. And then there's my divisor. So final answer is x squared minus 2x minus 3 plus your remainder of x minus 2 over your divisor of x squared minus x plus 1. Excuse me. Okay, there it is. That is long division. So I'll keep going. We have a couple examples to go, but now you know how it works. Fill in your missing placeholders for missing powers, account for missing powers, and watch your signs. X to the fourth minus 2x cubed, and then, yep, okay. So next one, 3, 2, 1, 0, all accounted for. We're ready to go. X squared, division symbol, that should be in red. And then 4x cubed minus 3x squared plus x plus 1. Side work. 4x cubed over x squared gives me 4x. That'll go right there. And 4x times x squared gives me 4x cubed. We subtract. These are gone. Everything else comes down. Negative 3x squared plus x plus 1. Side work again. Negative 3x squared over x squared gives me negative 3. That'll go above. And negative 3 times x squared is negative 3x squared. Subtract. These cancel. Everything else comes down. X plus 1. Look at that. We are done. There's quotient. There's remainder. There's divisor. Answer. Quotient, 4x minus 3 plus remainder, x plus 1 over x squared. Not bad. Okay. Okay. Again, right? 4 missing x cubed. You have 4, 3, 2, 1, 0. So all we're missing here is x cubed. 4, 3, 2, 1, 0. So account for x cubed. Four, 3, 2, 1, 0. And we're ready to go. All powers are accounted for. Set up. And side work. Five x to the fourth over x squared gives me 5x squared. That'll go right up there. And 5x squared times x squared plus 2 gives me 5x to the fourth and 10x squared. So we don't get another x cubed, but we get a 10x squared. Operation is subtraction. And 5x to the fourth minus 5x to the fourth, gone. 0x cubed minus 0x cubed, gone. Negative 3x, so again, be careful with your signs. Negative 3 minus 10. Negative 3 minus 10, we go more negative. Negative 13x squared, everything else comes down. All right. And then side work trick. Negative 13, and then put that above. I'll have, we could do this. Because we didn't get an x term, but then I get a minus 13. All right. And then negative 13 times x squared is negative 13x squared. Negative 13 times 2 is negative 26. So no x term here. And minus 26. Operation is subtraction. 13s will cancel. X minus 0x is still x. And now watch your signs. 1 minus minus 26 becomes plus. So we get plus 27. And we're done. Here's your quotient, remainder, divisor. Final answer. We don't need that 0x. I just put it as another placeholder just to keep everything proper. So final answer is 5x squared minus 13 plus remainder over divisor. Okay, and there it is. That's another long division. Account for powers and watch your signs. All right, perfect. You get 13, you get 10, okay. Last one. Oh man, look at all those letters. Okay, so looking at the first one, oops, we're missing a lot of powers. We just have x to the 5th. That's it. So we need to account for all the missing powers. So you see how we're not accounting for the missing powers of A? And that is because that is considered a constant. There are no variables attached to that A. So A to the 5th is a constant. So we only need to account for missing powers of what? Missing powers of x. Okay. Which means we're ready to go. Divisor, x minus a. Division symbol, and dividend. Side work. X to the 5th over x will multiply by x to the 4th. And x to the 4th times x minus a is x to the 5th minus ax to the 4th. And just like all the other ones, that goes underneath here in the right places. X to the 5th minus ax to the 4th. Operation is subtraction. Your x to the 5th, gone. Watch your signs on the next one. 0 minus minus a minus minus becomes positive. And bring everything down. And side work trick again. Oh, what did I forget? Don't forget to put that as your quotient. We multiplied by x to the 4th. Okay. Keep going. Now it's ax to the 4th over x, and we get ax cubed. So that's going up here. And then ax cubed times x minus a. And ax to the fourth minus a squared x cubed. Operation is subtraction. Ax to the fourth, gone. 0 minus minus becomes positive ax squared x cubed. Everything else comes down. Wash, rinse, repeat. Do it again. Same story, right? So put it underneath, subtract, it's a new color, orange, gone, minus minus, do it again and again and again. A cubed x. All right, still going. So now these cancel, and once again, 0 minus minus. You're not going to believe how this works out. Trick it again, side work trick. It's going to be amazing, watch. And oh my goodness. Gone, gone, remainder of 0. Wow. And don't forget all your terms, right? So I didn't put so our final answer is just, since there is no remainder, right? Since our remainder is 0, our final answer is You can't see that. And there you go. Pretty amazing, if you ask me. Because what you just witnessed was that you know how to factor, well, you now know how to factor a difference of fifths. Yeah, right? Remember the original problem was x to the fifth minus a to the fifth. And that looks kind of similar, right? If you gave us x squared minus a squared, that would factor to x plus a, x minus a. And then if you gave us x cubed minus a cubed, that would be a difference of cubes, which is factorable. If you gave us, if we gave you x to the fourth minus a to the fourth, that is also a difference of squares. But then they gave us x to the fifth minus a to the fifth. That is a difference of fifths. And by long division, you just proved, you just witnessed that you can factor a difference of fifths. A difference of fifths would factor to what we just found. X minus a times x to the fourth plus ax cubed plus a squared x squared plus a cubed x plus a to the fourth, and that's what it would factor to. It's amazing. This is why I say everything's factorable. You did not know that. You now know the formula to factor a difference of fifths. And we just proved that by long division. Cool stuff today. You're just like, yeah, whatever. That was a lot of math. It's over. I think it's over. Just stuff to notice. I mean, when will you ever factor a difference of fifths? Probably only in this class. But just know that you can. And it was a good time doing it. Okay, that is long division. That is it. Till the next one. The easier one, synthetic division, which will be next.